Suppose if there is any IO operation required for a process, such processes are placed in a device queue. The new state of information is updated into the process control block, that is into this PCB. The IO device is not ready to be served, then it becomes the IO device queue. That means the process is placed in the queue called a device queue. Hello everyone, it is Dr. Ravikumar YB, Department of Computer Science, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. In today's class, we shall discuss about the process scheduling. In the previous class, I have explained about process schedulers. The schedulers are the job processing CPU scheduling algorithms that is going to handle the scheduling process. Then the scheduling is done by the CPU. Then which are the different types of scheduling available here? That is, the first one is first come first serve CPU scheduling algorithm. The next one is priority scheduling algorithm. Third one is shortest job first scheduling algorithm. In that shortest job first scheduling algorithm, you will come across two different types of shortest job first scheduling algorithm. That is preemptive shortest job first scheduling and non-preemptive shortest job first scheduling. Then you will come across the round robin CPU scheduling algorithm. All these are different types of process scheduling algorithms done by the operating system, which you are going to study in detail in the next and subsequent slides. But in this session, you will learn in a brief about the process scheduling. If that is the case, let me take you into the process of scheduling. Process scheduling is the activity of the process manager. That is, the manager is the one who is going to manage and handle all of these resources, that handles the removal of the running process from the CPU and the selection of another process on the basis of a particular strategy. Then, process scheduling is an essential part of multi-programming, because suppose if I want to do multiple execution of multiple programs, then I can do so with the help of different processes. Such operating systems allow more than one process to be loaded to the executable memory at the same time, and the loaded processor shares the CPU using time multiplexing. As I told you that suppose if there are multiple processes, that is each of these processes can be used for doing execution of multiple programs. This execution of multiple programs at the same time requires sharing of resources. That means sharing of resources. In terms of time and CPU computation and all those things. If that is the case, OS maintains the process control blocks in the process scheduling queues. What is the meaning of process scheduling queues? That means which process is to be executed next is scheduled by the schedulers. So we will call these as process schedulers. The schedulers are the one which is responsible for scheduling or associating each of these processes to many of the resources. That's why we call it as process scheduling. The OS maintains a separate queue for each of the process states and PCBs of all processes in the same execution state and placed in the same queue. That means the OS maintains a separate queue for each of the process states, and PCBs of all processes in the same execution state are placed in the same queue. That means if process P1 and P2 are in waiting state, P1 and P2 are placed in the same queue. If P3 is in ready state, it is placed in ready queue. That is, P3 is placed in ready queue because it is ready for execution. So that's why we will place it in ready queue. When the state of a process is changed, its PCB is unlinked from its current queue and moved to a new state queue. That means the process control block contains the present state of a process. When the process changes its state from waiting queue to the ready, immediately the process control block changes the status of it and it becomes a new state. The new state of information is updated into the process control block, that is into this PCB. If that is the case, the operating system maintains the following important types of scheduling queues, which is that job queue. The first one is job queue. Second one is ready queue. Third one is device queue. We have these different types of queues here. This queue keeps all of the processes in the system. That means the job queue keeps all of the process. All processes are kept in a job queue. Initially, that means initially. Then these ready queues are responsible for keeping only the process which is ready for execution. That means once it is ready for execution and waiting to execute. That means ready for execution. A new process is always put in this queue. That means when the new process is created and it is ready for execution, we place those processes in the ready queue. That means the ready queue is one responsible for holding the processes which are ready for execution. That is called as a ready queue. If that is the case, we have a device queue. Suppose if there is any IO operation required for a process, such processes are placed in a device queue. That means unavailability of an IO device constituted this queue. That means suppose if the process is waiting to perform any IO operations, but the IO device is not ready to be served, then it becomes the IO device queue. That means the process is placed in the queue called a device queue. If that is the case, you shall see the pictorial representation of this. All the processes initially are placed in the job queue. Once it is admitted to the ready queue, it is given to the CPU. While executing the processes in the CPU, if there is any IO operation occurs, it moves to the waiting queue, then IO device queue, from here to the ready queue once again, then the execution. This in turn comes to the exit. Suppose if there is any other information, this indicates that the dotted line indicates that the device is waiting for an execution of a process, then we put inside once again into the ready queue. So this is how the pictorial representation of the program execution is shown. Then, as I told you at the beginning, first come first serve or first in first out, round robin, CPU scheduling, priority queue, shortest job first are some of the scheduling algorithms or policies followed by the operating system to process the scheduling of a processes. If that is the case, OS scheduler determines how to move processes between the ready and the running queues, which can only have one entry per processor core on the system. As I have already told you that if the processor is dual core processor or a quad core processor or an octa core processor, then it is very good. Suppose if it is a single core processor, entity per processor core on the system, then it is very difficult to schedule the processes for execution. So in such cases, the schedulers are used. These schedulers are going to schedule. That means we have timetable at which time which process is to be executed, at which time which is the next process to be executed. All those things, schedulings are done by the schedulers. Different types of schedulers are long-term scheduler, short-term scheduler, medium-term scheduler, as I have already discussed in the previous session. What is the main task of this? Main task of this is to execute the program. That means to select the jobs to be submitted into the system and to decide which process to run is called as the schedulers. There are three different types of schedulers. One is long-term scheduler, another one is short-term scheduler, third one is medium-term scheduler. If that is the case, what is the meaning of long-term scheduler? A long-term scheduler determines which programs are admitted to the system for processing. That means all of these processes that takes more time for execution is called as a long-term schedulers. Example, device queue. Long-term schedulers. Long time commitment, involved processes, are called as long-term schedulers. Example, device queue. The CPU scheduling involves another type of queue, that is short-term scheduler. The primary objective of this job scheduler or the device queue is to provide a balanced mix of jobs such as both IO bound and process bound. It also controls the degree of multi-programming. Please understand this very carefully. This point is very, very important, because if the system is a mixture of IO bound process and CPU bound process, then the system is called as a balanced system, because it contains, it increases the degree of multi-programming as a result of it. as a result of which efficiency of the system also increases. If the degree of multiprogramming is stable, then the average rate of the process creation must be equal to the average departure rate of the processes leaving the system. The number of processes enters the system and the number of processes leaves the system are equal, then we state that the degree of multiprogramming is stable. Suppose if more number of processes enters the system and less number of processes leaves the system, then most of the processes will remain in waiting queue. That is not called as a stable multiprogramming. The same thing is explained here. If that is the case, on some systems, the long-term scheduler may not be available or minimal. Time-sharing operating systems have no long-term scheduler. That means these time-sharing operating systems, that means RTOS, will not support long-term schedulers. When a process changes the state from new state to ready state, then there is a use of long-term scheduler. That means when the process changes its state from this is called as a new state, ready state, running state, waiting state, exit state, from here to here, here to here. So these are the 5 different states in which when the process changes its state from new state to the ready state, immediately the status information must be updated in the process control block and immediately that gets added into the long-term scheduler. So what about the short-term scheduler? The schedulers which are responsible for executing the CPU processes, are called as short-term schedulers. The CPU bound processes are called as the short-term schedulers. The CPU bound processes These short-term schedulers are also known as dispatchers, which makes the decision of which process to execute next. That means which is the next process to be executed is decided by the dispatchers, also called as short-term schedulers. The other name for short-term schedulers is dispatchers. Then short-term schedulers are faster than the long-term scheduler. As I told you that it requires executing the process. Execution of a process is done by the dispatcher, so it takes less time in comparison with long-term schedulers. Then we have medium-term scheduler. What is the meaning of medium-term scheduler? Suppose if the process is waiting in a queue, medium-term scheduler is a part of swapping. I told you that this is the main memory and OS is reserved for this. P1, P2, P3, P4 are there and this is the hard disk, also called as secondary memory. When the process P1 is to be replaced with process P5, then P5 must be brought from here to here. P1 must be swapped out. This time is called as a slack time. So this time is very, very important here. Again, the swapping is done by the scheduler called as medium-term scheduler. So it reduces the degree of multiprogramming. If the degree of multiprogramming is reduced, then obviously that results in a less efficient system. So this is how the medium-term scheduler leads to an inefficient system. A running process may become suspended if it makes I/O request. A suspended process cannot make any progress towards completion. That means it is kept in a device queue, or it is in the process of swapping the process from the current RAM or main memory to the secondary memory and secondary memory to the main memory. If that is the case, to remove the process from the memory and make space for the other processes, the suspended process is moved to the secondary storage. The same thing is explained here. This process is called swapping, and the process is said to be swapped out or rolled out. Swapping may be necessary to improve the process mix. That means to execute all of the processes in main memory, it is necessary to swap out or roll out the process from main memory to the secondary memory. This is how the long-term, short-term and medium-term schedulers works. Thank you very much. I am going to conclude this session. If you have any questions, I will be available in the department. Come to college and ask me any questions related to operating systems. Thank you very much. Thank you one and all.